Alright, our next unit, we are graphing our trig functions, and today we're going to start by looking at graphing sine and cosine. It's somewhat difficult to explain, but once it's explained and you get your hands on it and you start graphing it, it's not very hard to do. But it's difficult to explain and to initially grasp. Once you get past it, then you should be fine with it. This is usually my highest. People usually do well on this test whenever you're graphing the trig functions. So it's usually my highest test grade. So we're going to graph sine and cosine. So we want to look at sine first. So y equals sine of x is what we want to graph first. Now, if we don't know what it looks like, if we want to graph something and we don't know what it looks like, what should we do to get started? Besides put it in the calculator. That's all I need.
Find some points.
Find some points. I will make a table. Very good. Thank you. So I want to set a table up. So I want some x. And when I put something in for x, I want to get something out of it. Now, what type of number do we put in for x?
The special 30, 60, 45.
And what do those represent? Angles is what I'm looking for. We put angles in. Don't we put angles inside of the trig function? So we're going to put angles inside. So angles are what we're going to plug in, and we're going to get numbers out. Now notice at the bottom of our graph, what are our angles in? What form are they in? They're in radians. So when we put something in, we're putting it in radians. Drawing on my desk. Here. I said quit drawing on my desk. What were you doing?
Just coloring this in.
Don't color. Alright, so what's a good number to start with?
30.
0.
0 is a good number to start with. What's another angle I want to plug in there? 30, which is pi over 6. That's another good angle.
30, 60, over 3.
Pi over 3 is eventually, but there's something between. Pi over 4 is next. Then pi over 6. And there's one more I want to put in.
30 or 6?
Sorry. Pi over 3. And then we want to put in pi over 2. So those are some values we should be able to get some y values from fairly quickly. Okay? Now, what type of angle is 0?
It's a line.
It's a line. Non-existent.
Starts with a Q. Quadrantal. How do we evaluate quadrantals? I need a point. So what's my point for 0? 1, 0, which means my R is 1. Definition of sine? Y over R. So my Y value is 0 over my R value means it's going to give me 0. Pi over 6 is what in degrees? 30. What's sine of 30? 1/2. Pi over 4 is what in degrees? 45, which is what sine of 45 is? 1 over the square root of 2. Pi over 3 is 60. What's sine of 60? Square root of 3 over 2. Then we get to pi over 2. What type of angle is pi over 2? Quadrantal. What's my ordered pair there? 0, 1. My R is 1. Definition of sine? Y over R. So 1 over 1 means I get 1. So let's plot the points we have so far. 0, 0. Then I've got pi over 6 and 1/2. Pi over 6 and 1/2. About right there. Then I have 1 over the square root of 2 is approximately 0.707. So pi over 4 is right here in the middle. 0.707, about right there. Square root of 3 over 2 is 0.866. So 0.866. About right there. And then I get to pi over 2, which is 1. Pi over 2 is right here. 1 is right there. So I connect those. And it should be a curve. But I need to continue on. What's a number bigger than pi over 2? That would be next in line. No, there's 3 numbers in between pi over 2 and pi.
over 3.
2 pi over 3 is correct, Matthew. After 2 pi over 3.
It's 3 1 more than the denominator, right?
Right, so which one needs to be next?
3 pi over
3 pi over 4.
4. 5 pi over 6.
5 pi over 6. And what did you say, Kaylee? Pi. So we want values for those. Now, what do I know about sine of pi over 3 and sine of 2 pi over 3?
It's twice as much.
The angle is twice as much, but the sine value is not twice as much. What do I know about sine of pi over 3 and sine of 2 pi over 3? They're the same. Because remember, I've got an angle here in quadrant 1 and an angle here in quadrant 2. The ordered pairs of those two angles are the same, except what's different in quadrant 2? The x value is negative, but what's true about the y value, which is what I care about since I'm dealing with sine? The y value is still positive and it's the same number. So since my ordered pairs since my y values for each of them are the same, that means it's going to produce what? The same number is what I'm looking for. Since my y values are the same at both spots, it's going to produce the same number. So that means 2 pi over 3 is going to give me the same thing as pi over 3. That means 3 pi over 4 gives me the same thing as pi over 4. And 5 pi over 6 is going to spit out the same thing as pi over 6. Which gives me 1/2. Okay, and then what about pi? What are we dealing with pi? We're dealing with a quadrantal. What's my ordered pair for pi? -1, 0. My r is 1. Definition of sine? Y over r, so that makes it 0 over 1, which gives me 0. So I've got some more points. So I have 2 pi over 3. Now, where do you think 2 pi over 3 is at? The next full mark. Notice pi over 3 is right here. Pi over 2 is right there. They are 1 apart. So that means 2 pi over 3 is going to be right there. So 2 pi over 3 needs to be that 0.8661 right there. Okay? The next one is 3 pi over 4. Where's 3 pi over 4 going to be?
No.
It's not the next major mark. It's half. It's halfway. If you notice over here, notice that pi over 4 is halfway in between two major marks. So this one means that pi over 4 is going to be right there. Okay, and then what about 5 pi over 6? It's the next major mark, so it's going to be right there, so that is 1/2. And then once we get back to pi, we are at 0. So there's my curve. Okay, so what would my next angles I should be considering? I keep going. What are my next angles? 4 pi over 3, 5 pi over 4, 7 pi over 6. Now, 7 pi over 6 should come first. Because if you remember, the pi over 6 are closest to the x-axis, and the pi over 3s are furthest away. So my next ones are going to be 7 pi over 6, 5 pi over 4, and 4 pi over 3. But what happens, where are those angles at? They're in the third quadrant. What happens to sine in the third quadrant? It becomes negative. So I'm going to get the same numbers again, except now, what's going to happen to them? They're going to be negative. So what is my graph going to do? It's going to go under, and it's going to look exactly like this is. Because my next two quadrants are quadrant 3 and quadrant 4, and what's sine in both of those quadrants? They're negative, and they're negative of these numbers. So my next piece of graph should look exactly like this, except it should be underneath. So what we want to do is we want to notice how far apart are these two. They're 6. They are pi apart. So I want to go to 2 pi. And then notice halfway in between what happens. Where am I at? I'm at 1. So halfway in between over here I need to be at -1. And does it make sense that I'm -1 at 3 pi over 2? What's my ordered pair at 3 pi over 2? No.
0, -1.
0, -1. And if I do sine, that makes it -1 over 1, which gives me this. So then all I've got to do is connect these. So it gives me that. Now, what's going to happen if I want to go past 2 pi? It's going to go back up to the top. Okay? So I had 6 here, I had 6 here, I'm going to go another 6. And then what has to happen halfway in between? It goes to 1. So we're going to have a curve like this. Okay, what about over here on the left side of 0? It's going to go under. So I go 6 again. And then halfway in between. Okay, and this continues on in both directions. Okay. That's why I'm sure you've heard this term a sine wave. Have you ever heard the term sine wave?
No.
That's why it's called a sine wave, because if you notice, it's just a wave. It continues and repeats itself on both directions. Okay. So, here's what we're going to do to graph this. We do not need a T-chart every time we graph this. There are certain things we're going to focus in on, and when I have those certain things, it makes it very easy to graph this thing. So what do you think those certain things are that I need to find? Quadrantals are the ones that are important, because what are the quadrantals going to produce? What values? They're going to produce 0, 1, or -1. So if you notice, my quadrantals were here, 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 and here, and so on. Okay, so it's got to be 0, 1, or -1. So we're going to focus in on our quadrantals. Okay. My next question is, how long, if I started right here, if I started at 0, how far did I have to go before this graph started repeating itself? Did not. It went 12. 6 gets me from here to there, but 12 gets me back in the same position as I started. Okay, so that's the same again. It had to go 360, and it should make sense, because if I'm here and I go all the way around and I get back to 360, what's going to happen? I'm going to start over again. So every time I start over again, that's when a new piece of the wave begins. Okay? So what we're going to do is we're going to figure out how far it is from where I start to where I end. That is called the period. The period is the distance it takes for me to do a full piece of the graph. The distance it takes for me to start and get back to my starting position, to where I'm ready to do it again. Okay? So I started here at 0. I had to go back to 0, and then down, and then back to 0. And now I'm ready to mimic my piece of graph. So how far did I go on this one? Didn't I go 2 pi? Okay. I went the full distance of 2 pi before I started over again. Okay. The other thing I want to know is, what is my amplitude? What do I mean by amplitude? Close. In this case, my amplitude is 1. So what is my amplitude? It's from the middle to the top, or from the middle down. It's how high you go or how low you go from the middle. Okay? So in this case, I went from the middle, I went up 1, and I went down 1. That's my amplitude. Alright, so once we get the period, we are going to mark our starting point, which is right here, and we're going to mark our ending point, because what has to be true about my starting point and ending point? They have to be the same. So you're going to do that. Then we're going to take half of that. So we're going to take that distance. So half of 2 pi is pi. Notice what's happening there. I'm at one of my quadrantals. Then I take each one of these distances and cut it in half. Notice what happened again. I'm also at my quadrantal. So when I take half of my period, that puts me at a quadrantal. When I take half of each one of those, that also puts me at a quadrantal. So I found my quadrantals. As soon as I find my quadrantals, I have to be one of three values of my quadrantal. What are my three values? 1, 0, or -1. I have to be one of those three things. Okay? Notice, right here at pi over 2, I'm at the y value of 1. Before I can get to the y value of -1, what do I have to be?
0.
I have to be 0. Notice I cannot go directly from a high to a low without going to 0 in between. That's important. Okay? Anytime you want to go from a high to a low, you always have to hit a middle. Anytime you want to go from a low to a high, you have to hit a middle. Okay? That's very important with the path. Okay? So, let's graph one. All right, I have y equals 3 sine of x. Or sorry, that's not what I want. I want 2x. Y equals 3 sine of 2x. So, what do we want to do?
Make a table.
We don't need to make a table anymore. I have to figure out two things. I have to figure out my amplitude and I have to figure out my period. What do you think my amplitude is going to be?
3.
3 is my amplitude. The number out front tells me my amplitude. To get the period, there is a formula to get the period. The formula to get the period is 2 pi over b. B is the number that is directly in front of x. So on that first problem we did, what was the number in front of x? 1. So 2 pi over 1 gives me 2 pi. That's why my period was 2 pi on that first one.
Okay.
On this one, it's 2 pi over 2, which means my period is pi. So we're going to start at 0. What do we know about sine of 0? It's 0. That's one thing we need to know about sine. Sine is going to start at the origin. Sine starts at the origin, so that's something we need to know about sine. Okay? What else do I know about this problem?
It's going to be 3 away from the x-axis.
At pi, I need to be back to where I started. How do I know that?
Because the period is.
That's what my period is. Now what do I want to do? I want to do half. So half of that, so there's the end, there's the beginning, half of that is that, and then I want to take half of each one of those. Because what has to happen at each one of those marks? It's a quadrantal, which means I've got to be 1, 0, or -1. Yes?
So in saying that, would you say that the period between 0 and pi would have to be 3 up from the from the x-axis?
Yes, I'm going to have to eventually, my high point is going to be 3 up, my low point is going to be 3 down. That is correct. Okay? So the next thing I need to know is, at this first quadrantal, am I going to be a high point or a low point? I'm going to be a high point, because sine, a positive sign always goes up first. So I'm going to be at a high point right there. And what does my next quadrantal need to be? It needs to be a middle point. It needs to be a 0. And then what does my next one need to be? It needs to be -3. Which gives me that.
Yeah, I thought you said it had to be 1.
Say it again.
I thought you had to be 1 or -1.
It is. It is 1 or -1, and then I have to multiply it by that number. And that's what makes it 3 or -3.
Okay, I see how this works.
So then, make sure it's a curve. You do not connect these with straight lines. They are curves when you connect those points. Okay, and that right there represents one period. Whenever I have you graph, I want you to graph 2 periods. Okay, which means I want 2 of those. So what am I going to do to get 2 of those?
Do it again.
Do it again, but how do I know how far to go?
Copy.
6.
I went 6 spaces from where I started to where I ended. So that means I need to go another 6 spaces. So that's going to put me at 2 pi, and I know I've got to be at the same spot. Okay, then I cut that in half again, and cut each of them in half. So what does my next dot need to be?
3.
It needs to be up here at 3. The next dot, 0. The next one, -3, and then we're back to the middle. Connect those with the curve. And then we want to put arrows on each end. That way we are showing that we understand that this graph continues on to the right and it continues on to the left. I want you to notice something. There are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 dots in 2 periods. So whenever you're graphing 2 periods, a quick way to check whether or not you got 2 periods is whether or not you have 9 dots. 9 dots will give you 2 periods worth. Okay, so let's recap what we did on this problem. What did we do first?
Figure out the amp.
Figure out the amplitude and the period. Okay, and then what do we know sine always does? It starts at the origin, and if I start at the origin, where do I need to finish? At a 0, on the x-axis. Remember, I've got to start and finish at the same spot. Once I figure out where I start and finish, I cut that in half, and then cut each half in half. Okay, and then from there, each one of those has to be a high, a middle, or a low. And you just continue the pattern. And I need 9 dots. Okay, so that's graphing sine. Let's look at cosine. What do you think is going to happen with cosine?
It's going to be opposite.
Kind of opposite,
But
yes.
somewhat same.
It'll be on the Y.
No.
Dreams first.
Yeah. All right, so let's do the t-chart real quick. So I had x. I need 0. I need pi over 6. I need pi over 4. I need pi over 3. I need pi over 2. I need 2 pi over 3. I need 3 pi over 4. I need 5 pi over 6. So let's get those values. Once we get those values, we'll have a pretty good idea of what this graph will do. So again, what type of angle is 0? Quadrantal. What's my ordered pair there?
1, 0.
1, 0. I wish you guys would get that in your head. Those quadrantals, you've got to memorize those ordered pairs. Makes life much easier. Okay, definition of cosine. X over r. So 1 over 1 means that is 1. Pi over 6 is 30. What's cosine of 30? No. Square root of 3 over 2. What's cosine of 45?
1 over the square root of 2.
1 over square root of 2. Cosine of 60? 1/2. Then we're back to pi over 2. What is pi over 2? Quadrantal. What's my ordered pair? Taking too long.
1,
0.
0, 1. Let's go. My R value is 1. Definition of cosine.
X over R.
So that makes it 0. All right, now let's get back to 2 pi over 3. What happened when I was dealing with sine and I got to 2 pi over 3? It stayed the same, but with cosine, what's going to happen?
They're going to be inverse.
It's going to be the same number, except this time it's going to be negative. So 2 pi over 3 is going to be the same number as pi over 3, except it needs to be negative. 3 pi over 4 is going to be the same number as pi over 4, except it needs to be negative. 5 pi over 6 is the same thing as pi over 6, but it needs to be negative. And then we need to get back to pi. What's my ordered pair for pi? Negative 1, 0. My R is 1. Definition of cosine. X over R, so that means it is negative 1. So let's see what these points do for us. So I have 0, 1. Then I have pi over 6 radical 3 over 2, which was about 0.866, so that's about somewhere up in there. Then I have pi over 4, 1 over radical 2, which was 0.707, so somewhere about there. I have pi over 3 and 1/2. And then I have pi over 2 and 0. So this looks like that. Then I move on. 2 pi over 3 gives me negative 1/2. 3 pi over 4, negative 0.707. 5 pi over 6, negative 0.866. And then pi, I'm at negative 1. What's going to happen as I continue on to the right? It's going to go up again. Where's it going to end up at eventually? It's going to get. When is it going to get back to 0? 3 pi over 2 is going to get back to 0, and I've got a curve. Okay. When's it going to get back to its height? It's going to get back to its height at 2 pi. Okay.
So it's the same as just starting at 1?
It's the same curve. It's just starting in a different spot. Sine and cosine are the same curve. They're just starting in this different spot. Now, why does that make sense? Why are they the same curve? What do you know about sine and cosine?
Because they're sides of a triangle.
Not really what I'm looking at, but possibly, kind of. What are the only? Let me think. 1, 2, 3. Hold on. 1, 2, 3, 4, 5, 6. What are the only 6 things that sine can equal? That we have memorized. What are the only 6 things sine can equal? Well, go with me. What are the only 6 things sine can equal? 1/2, square root of 3 over 2, 1 over square root of 2, 0, 1, negative 1. Those are the only 6 things sine can equal that we have memorized. What are the only 6 things cosine can equal that we have memorized? All those same numbers. They both equal the same numbers. So if they both equal the same numbers, then that means their graphs should look very similar. They just equal those same numbers in different spots. Okay? And that's why the graph has changed. Okay? So we're going to do the same thing on cosine that we did with sine. Except what's the one difference? It's going to start at a different spot. Okay? It's going to be exactly like it was with sine, except we're going to start at a different spot. So where do we notice sine start or cosine starts? 0, 1. But let's get less specific than 1 because it's going to change. It's not always going to be a 1. So where can we say it starts? It starts on the y-axis. And what I'm looking for is it starts at the amplitude. Cosine is going to start at the amplitude. Where does sine start? At the origin. Sine starts at the origin, cosine starts at the amplitude. Okay, everything else is going to be the same. We find the period in the same manner. Okay, the equation for the period is still going to be 2 pi over b. Alright, so let's graph one. I have y equals 4 cosine of 2 over 3x. Y equals 4 cosine of 2 over 3x. So, what do we want to do first? Amplitude. What's my amplitude going to be? 4. My amplitude is going to be 4. So what does the amplitude tell me?
Where you're starting at.
Yeah.
It can only go up to 4, and it can only go down to negative 4. Alright, what else do I want?
Period.
Period. How do we find the period? 2 pi over b. So in this case, I've got 2 pi, and my b in this case is 2 over 3. How do we handle that?
This is a 4/3 pi.
How do I handle that?
Okay.
Multiply by the reciprocal of your denominator. So it's going to be 2 pi times 3 over 2. So what do we end up with? 3 pi.
wanted to know.
Yeah,
I'm
I
glad
know.
you're here.
I just want you guys to have a chance.
6, yeah, 6 divided by,
Okay. So now I'm ready to go to my graph. What's the first thing we're going to do when we go to the graph?
you start off at
Starting point. Where's it at?
4.
At 4. It's going to start at 4. What's the next thing I want to do?
Find how
How
long
far
the
you're
period
gonna go?
is.
What's my period? So my period is 3 pi. What's going to happen at 3 pi? Where's my graph going to be?
It's gonna start.
It's going to be at 4. Why does it need to be at 4?
Is it a start square?
Because it's got to start and finish at the same spot. Now what do I want to do? Half of it. So I'm at 3 pi. What's half of 3 pi? 3 pi over 2. Then I want half of that. Okay? Half of 3 pi over 2 may be tough to find, so we want to count how many boxes there are and just half the number of boxes. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So half of 9 is 4.5. So 4.5 is going to be in the middle, and 4.5 is going to be in the middle there. Alright, so this starts up here at 0, 4. On my next mark, where do I need to be? I need to be in the middle.
No,
Where does my next mark need to be?
down 4.
Down 4. My next mark
0.
needs to be at 0. Okay? Then you connect your curves. Make sure it's a curve. Connect your dots with the curve. Alright? Now when I graph something, how much do I want?
2.
I want 2 periods, which represented in how many dots?
9.
9. Now there's not going to be enough spaces for 9 dots, but you need to put as many dots as possible. So that means I now need to go to the left and find some dots to the left. How far do I need to go to get to my next dot?
4.5.
4.5. So where's that dot going to be when I get to 4.5?
Yeah.
It's going to be back at the middle. So 1, 2, 3, 4.5. I've got to have a dot there. So I connect that curve. Okay, and then how far do I go to get to my next dot? 4.5. So there's a half. 1, 2, 3, 4. Where should it be?
Down.
-4. 1, 2, 3, 4. Which is right there. So I connect that. That's as much as I can do. It's not 9 dots, but it's still as much as I can graph on my graph. So, when I'm graphing sine and cosine, what do we do to get started? Amplitude and period. How do you get the period? 2 pi over b. Where do you find b? The number in front of the x. How do you get the amplitude? The number at the very front. Okay, after I have all that, what do we want to do next?
Find half period.
Figure out where it starts. Where does sine start? Origin. Where does cosine start?
Amplitude.
Amplitude. Then what do I want to figure out? Where it ends. And it has to start, or it has to end where it started. After that, I'm chopping it all up. And then at each one of those marks, I have to be one of 3 things. A high point, a middle point, and a low point. And then you just continue. How many dots do we want total? 9. Now, on your assignment, sometimes there's going to be a negative out here in front of the number in front of sine or cosine. What is that negative going to do to me?
Where you go down.
It's going to flip it. So, sine normally starts at the origin and then goes up. But if it's negative, what's going to happen?
It's going to go down.
It's going to go down. Cosine, what's going to happen when it's negative and it's cosine?
It's going to start at -4.
It's going to start at -4 and then it's going to go up. So that's what the negative does to you. It flips you. Okay? All right.